making some tape to mark where I'm going to throw the ball from. I'm going to drop a ball from the roof, 2 balls from the roof, and I'm going to see where it is at what time. I'm going to videotape it in slow motion and see where it is using that chart over there. So that's the camera to videotape where it is at what time. We're using the computer to control the camera because you can't touch this phone while you'll have to be picturing it, so you won't be able to touch over here. I'm going to drop a basketball and a doggy ball. Okay, just throw it. That's to mark where I'll drop it from, so I'll be able to drop it from the same spot every time. Top. This ball is bigger. This one will be farther ahead than this one. So when it first starts. When we do this data analysis, we're going to take away the difference. I threw the ball 10 times, and this tells you which number of times I threw it. This is, right now I'm doing the first one. The second one, frame of release, is when I release the ball. When the ball moves, the one right before that is the time it releases. And this is the 205th picture in the video. So that's why it's 205. So we look at what position the ball is at like what time. The next one is the ruler mark. It's where the closest ruler mark is. Right now the ruler marker should be about 1.5, but it's not exactly 1.5, so we have to measure how far it is. We're going to measure the distance between the ball and the ruler mark. The number is 51, and then you just go and record it. Brightness and some contrast, so you'll be able to see the ball better and where it is. But sometimes it just makes it more blurry, so. Too bright. And that's about good. There. In a second, there is 120.4024 frames. To measure it in seconds, we do the current frame minus the frame of release divided by 4024 And then, well, you sort of get how many seconds there are.
Mm-hmm.
We want to measure where the ball is in meters, but instead we have a foot chart, so we'll have to convert the foot into meters, multiply by 0.3048 and to do that. But the extra pixels are pixels, and we need foot, so we have to measure how many pixels are in a foot. Okay. 116. So in the parentheses we want the D2 plus E2, which would actually be the ruler mark plus the extra pixels. But now we know that 1 foot is 116 pixels, and so divide that by 116, and then times
parentheses
times 0.3048. I'm measuring the distance between the basketball and the little ball here to minus the difference for the data analysis.
Okay.
About 7 centimeters.
No, 17.
Oh yeah, 17 centimeters. I'm measuring the position of the release point in my data. I have position but I need distance, so I measure the position of the release point. I got 167 pixels, but we want meters instead of pixels. So here is the conversion, and the position is at negative 0.134 meters. We loaded the data file. We take the position and subtract the origin points. We plot the data points. The horizontal axis is what time it is, and the vertical axis is the distance it travels. The red dot is the small ball, and the blue dot is the large ball. You can see the trend. To find the trend, we need to do the regression. This is our result of our regression. Next, I went on Wikipedia and found what the result should be, and we got pretty close. Then I put the data points the regression results and the theoretical line on, and voila!